Hi, welcome to K Street Publishing's lesson on stairs. Now, you've probably seen a lot of different stair videos on YouTube for Sketchup. We're going to take a little bit different approach. We're going to take more of a realistic approach. We're going to take an approach that's based on code and it's based on realistic building situations. Here we have two floors. These floors are both framed out of TJIs, which are 11 and 7/8, plus plywood, 3/4 inch. We need to build a stair between the two. Well, when you're working with stairs, one of the main constraints of stairs is the code allowances. The building code allows you to have stairs of only a certain height and a certain tread width. So we're going to be using the IBC. The IBC is the International Building Code, which is used by most municipalities. In addition, they might make amendments or changes to this code, so you need to check with your local building code officials to see what amendments apply to your stairs. So in the section about stairs, it tells us our maximum height, the riser height of the stair, can be 7 inches, and the minimum is 4, and the tread needs to be 11 inches minimum. Now, they allow a little bit of leeway here. If you're in a single-family house or an individual residential unit, you can change this or increase it up to 7 3/4 of an inch with a 10-inch tread. So you can see here by our calculation, the height that we're working with was determined by pre-cut stud, 2 top plates, 1 bottom plate, gives us a height of 97 1/8 for our wall. Then the floor thickness is 12 5/8 of an inch because it's 11 7/8 inch TJI, 3/4 inch plywood. So it gives us a total height of 109 3/4 inches. We need to determine the number of risers. And the way we do that is take our height, 109 3/4 of an inch, divided by 7, and that equals 15. So if we want a standard tread, let's assume this is not a residential building, then we need 16 risers. So let's go back. We'll take our 109.3/4 and divide that now by 16 to find our exact riser height. So it's going to be 6.86. And we're just going to go with the standard 11-inch tread. So here we have our walls. Now I've made them a group because I don't want to have the stair stuck on here, because I might want to move the stair. I might want to rotate it. It's still a design element. I need to determine its size, but then I might modify its location slightly. Now you notice I'm working in X-ray mode. My face style is X-ray, so that I can see through the walls. If you don't like working in X-ray mode, you can turn that off. And let's zoom in to the area that we want to work on. Be sure and exit the group. So we're going to just pick a point. Right now it's not terribly critical because we're going to move the stairway back and forth. And how high do we want to go? So we'll just move it up, and then we'll enter 6.86. That is the height of our riser with a tread on top of it. So the tread is not in addition to this. And then what's our tread length? 11 inches. So there's the basic layout of our stair. Now you might say, well, that's not a real stair. It doesn't have nosing on it. Sometimes risers are put in a slope, but almost all stairs have nosing, so we need to decide how much nosing we want. And even the code tells us what our nosing height. See, our nosing cannot project more than 1.25 inches beyond the tread below. So we identify this line and this line by holding down our plus key, which is the control or command key, and we're going to make this a component. And we're going to call this stair 1. Now we're ready to copy this. We need to copy it all the way up. We need 16 copies. We have 16 risers. But depending on how we frame the top one, we could have 15, but we can change that a little bit later on. So we're going to go to our copy and identify our move command with a plus key then, which is control on the PC and command on the Mac. Identify this endpoint, and we want to move it to that endpoint. Now we'll hit 16 times. So 16x. Well, we already had 1 in there. Remember, we can always change that here. We can go to 15 times. We had 1 there. We added 15. So now we're at the right height. And you can see our top tread matches. So the next thing we need to do is we need to determine how we are going to define the nosing and the depth of the base of this. We need to draw the nosing. So to do that, we go into our component, click on it again, So it's an individual component, and we can work on it independently. We're going to rotate this around, then we're going to draw a nosing. Pick a line here, pull it in the green direction, 1.25 inches. And then how thick is it? Well, the standard, if we use a solid hardwood step, it's about 1.5 inches. So we're going to use 1.5 inches. And then we come back and hit this line. Now we're going to come in and erase that portion. So we have our first nosing. And you notice it put the same nosing on all the stairs automatically because we made it a component. Components can be 2-dimensional or 3-dimensional. Now we're going to use a fillet here. Under Tools, we've added a Ruby plugin called Fillet. We're going to identify this edge and this edge. Go to our Tools, Fillet command, and it wants to know radius. The code even tells us this. We're only going to use 1/2 inch. And we want to do the same thing on the bottom. So we identify this line, hold down the plus key, identify that line, go to our command, 0.5. And since it's a component, it's been reflected automatically in all these. Now we're ready to determine the bottom of our stair. Now you've seen in many of these training lessons where they just draw a stair and the stair has thickness all the way down to the floor. Well, that's obviously not the way that people build stairs. They build stairs with carriages that support the treads and support the risers. So we need to determine that. We need to draw a line from the base of this tread, or the top of the riser, to one up above. Now we're going to identify this line, and we want to move and copy it. We want to move and copy it on the wall surface. So be sure it says on the face, because we don't want it on the red axis. We want it on the face. And we want it 11.25 inches, which is the depth of a 2x12. Now I'm ready to extend this. The easiest way to do that is just draw another line. Lock it onto this endpoint. And you can see then it stays parallel to the edge that we originally had. So we'll keep it parallel to the edge and draw it up to here. Then we'll draw another line from here down, and we'll use our arrow keys to lock onto the blue axis. And then we need a base, because there is a line here, but it's inside the group that makes up the wall and the floors. So we'll draw another line from here to that intersection. And then we can delete this line, and then we'll go into this component, right-click on it, and say Explode. Now it's back to the original line work. Let's go to our outlining tool. Let's go to our outliner, and it'll tell us all the things that we currently have in the drawing. We want to turn off or hide the group, and we'll unlock it and then hide it. We're using that wall as layout for this stair. Now since all this stair, all these are components, we're just going to window this, right-click on the component, and explode them all.